Derivative of functions in parametric form. If relation between two variables is expressed by third variable, the third variable is called parameter. More precisely, a relation expressed between two variables x and y in the form x is equal to ft and y is equal to gt is said to be parametric form with t is parameter. In order to find a derivative of function with some
in such form, we have by chain rule.
Chain rule says derivative of y with respect to t is dy by dx into dx by dt. And dy by dx is dy by dt and dx by dt. Whenever dx upon dy is not equal to 0, yes, it's t, dx by dt is not equal to 0, we write derivative of y with respect to x is equal to g dash t upon f dash t as dy by td is g dash t and dx by dt is f dash t, provided f dash t is not equal to 0. Example first, find dy by dx if x is equal to at square and y is equal to 2at. So these are given. So dx by dt is at square, sorry, it's 2at, and dy by dt is 2a. So dy by dx is dy by dt upon dx by dt is equal to 2a upon 2at, which is equal to 1 upon t. Example 2, if x is equal to 3t square minus 1 and y is equal to t cube minus t, then find dy by dx. Given that x is equal to 3 square minus 1 and y is equal to 3 cube minus t, so dx upon dt is 60 and dy by dt is 3t square minus 1. So dy by dx is dy by dt upon dx by dt, which gives 3t square minus 1 upon 6. Logarithmic differentiation, y is equal to fx is ux raised to vx. So y is equal to fx into gx into hx. We differentiate such function by taking both logarithmic on both sides. This process is called logarithmic differentiate. Example 1, differentiate x raised to x with respect to x, means y is equal to x raised to x, taking logarithms on both sides. Log y is equal to x into log x. Differentiate both sides with respect to x, 1 upon y into dy by dx. Log x plus x upon x is equal to 1 plus log x. Multiplying y both sides, dy by dx is equal to y into 1 plus log x, x raised to x into 1 plus log x. So derivative of x raised to x is x raised to x into 1 plus log x. Example 2, y is equal to x raised to e raised to minus x raised to 2. taking log on both sides gives differentiate both sides 1 upon y into derivative of y is equal to y into e raised to minus x raised to 2 into 1 minus 2x square into log x upon x, which equal to x raised to e raised to minus x raised to 2 and following thing. Let y is equal to fx, then so there is one mistake, I clear this. This is our final solution. Derivative of y with respect to x is this. Higher order differentiation. Let y is equal to fx, dy by dx is f dash x. If fx is differentiable, we may differentiate it with respect to x. The LHS become again derivative, which is called the second order derivative of y with respect to x, and is denoted by d square y upon dx square. It is also denoted by f double dash x or d square y or d double dash or d2 y2. If y is equal to fx, we remark that higher order derivatives may be defined similarly. Examples: if y is equal to 3e raised to 2x plus 2e raised to 3x, d square y upon dx square minus 5 into dy upon dx plus 6y is equal to 0. We have to prove this. Given that then we common out 6. Now second derivative, here d square y upon dx square minus 5 into dy by dx plus 6y is equal to 6 into at the end, if we complete the operations, we get 0. Example 2. Y is equal to fx is equal to x cube plus 5x square plus 2x minus 9. Find second derivative of fx. So derivative of y with respect to x is equal to 3x square plus 10x plus 2, which gives f dash x. Differentiating again, so differentiate this thing again, differentiating 3x square plus 10x plus 2, which is equal to 6x plus 10, which is equal to f double dash x, also equal to d square y upon dx square. So d square y upon dx is called second derivative of fx. Gradient or slope of the curve Let y is equal to fx be a curve. The derivative of fx at a point x represents the slope of the tangent to the curve y is equal to fx at the point x. Sometimes the derivative is called gradient of the curve. Example first. Find the gradient of the curve y is equal to 2x cubed minus 3x squared minus 12x plus 8 at x is equal to 0 given. So dy by dx is 6x squared minus 6x minus 12. So derivative of y with respect to x at x is equal to 0 is minus 12. We put 0 on as x. So at the end, the gradient of the curve at the point x is equal to 0 is minus 12. Example 2. Find the slope of the tangent to the curve x squared plus y squared plus 2gx plus 2hy is equal to 0 at 0, 0 given. So derivative of x square is 2x, y square is 2y into dy by dx, 2gx gives 2g and 2hy gives 2h into dy by dx is equal to 0. Common out dy by dx from this and this gives dy by dx is minus x minus j upon y plus h. So dy by dx at 0, 0 is minus j upon h. Please do subscribe my channel. Thank you.